Today, we're going to talk about practical coding with large language models. And before I get started, I just want to preface this by letting you guys know that I am no expert, okay? I've been working with this stuff for a couple months. I'm an experienced software developer, but I'm very much exploring this world, and I'm inviting you folks to explore it with me. I'm sharing what I've learned so far, but I certainly don't want to pass myself off as an expert on any of this stuff. Okay. So with that in mind, um, if you want to run an LLM locally, there are some hurdles that you have to overcome. On the screen here, you can see some software resources that this is the path that I suggest for you to get started. This is really the most direct path that I've found. And it's something that is workable on multiple platforms. Olama is the server that provides the models and provides the chat interface to those models. You can work with Olama by itself, but I highly recommend installing Open Web UI. Open Web UI gives you a Chat GPT-like interface, all the stuff that you have come to expect from interacting with commercial models, a chat history, the ability to set up different sort of pre-configured versions of your model. All that good stuff is there. Plus, for our purposes, Open Web UI is great because it provides um, an open AI compatible API. Okay, so OpenAI are the people who make ChatGPT, and their API has become the industry standard. So what the script that we're going to share today is a script that I wrote for actually working with remote LLMs served up by a company called Nebius, and they use the OpenAI API. So it was really convenient to be able to sort of switch back and forth from remotely hosted LLMs to local LLMs by using the commonly used API. But you can certainly just talk to Olama directly. It's pretty easy to do if that's your preference. The reason that Docker is on the list of requirements here is because that is the easiest and fastest way to get Open Web UI installed. Just install it as a Docker container. There's a one-liner command that will do everything for you and basically give you a web appliance on your desktop for interacting with LLMs. So I highly recommend going that route. You can, in fact, install a copy of Open Web UI that has Olama bundled with it, which makes it even easier. I prefer to grab Olama on its own. I don't want that running in a container or anything like that, but there are multiple paths here. Okay, the hardware side. The bare minimum that you've got to have here is a modern CPU with 16 gigs of RAM. That is going to allow for very limited exploration of local LLMs. Very small models, extremely small models, will run on unaccelerated, just CPU, no GPUs, no special vector units, and regular RAM. So that's something that you can do if you want to. It gets you started, and if your budget is limited, you can master a lot of the techniques working with very basic hardware. One of the first machines that I tried to do this stuff on was a Lenovo P93, like one of those mini PCs, and with 12 gigs of RAM, and it's able to run the smallest models at acceptable speeds. And so my point being that you can use almost surplus hardware. If all you want to get is a taste and to learn the techniques, you can do that. If you want to do anything of any substance with an LLM, you are going to need at least those two items that we already talked about, plus an NVIDIA GPU with 4 to 6 gigs of RAM. My laptop has an NVIDIA GPU with 4 gigs of RAM. If you've got a gaming PC that was made in the last 4 or 5 years, you've probably got a machine with 4 to 6 gigs of VRAM. That will allow you to run some pretty capable models, including everything that we are going to look at today. Okay. You can do an awful lot with that scale of hardware without getting into anything bigger. In terms of exploring this stuff right now, I would say the easiest path to entry is if you have an Apple Silicon Mac. And the reason for that is the shared memory architecture of Apple Silicon allows you to run much larger models on a pretty basic setup. Because you can use the shared RAM, and you don't need to have exotic GPUs with lots and lots of VRAM. You can stock a Mac Mini with 48 or 64 gigs of RAM and run models that are really only attainable for people who have like dual GPUs and so forth, in terms of Intel setups. The trade-off is that Apple Silicon is a lot slower running inference. In my testing, it's 4 to 5 times slower. So though it can allow you to have access to much larger models than a comparable sort of consumer desktop on the NVIDIA side, the downside is that for the same model on hardware that can run it, you're going to get worse performance on the Apple device. So it's really only good for a single user or for experimentation and stuff. But there's a lot of potential there. So that's the basic landscape in terms of your requirements. If instead of using a local LLM, you would like to use a remotely hosted one, I recommend that you install Docker Desktop to be able to run this project, and then get yourself an API key from Nebius. It is IUS. I see that I've accidentally spelled it 2 different ways on the slide. The URL is right. It's Nebius. And what Nebius is a company that offers access to LLMs, many LLMs, and they offer some pretty unique features that are really valuable that I'll show you a little later. One valuable thing about Nebius is that when you create a new account, you get a $100 credit. So you're able to really explore, those credits will go a long way in terms of working with LLMs. I think that my first explorations of this space were with Nebius online, and I think I spent about $20 of my $100 credit, and using those $20, I built and tested an application. So it can go a long way. So one of those two paths is the way that you're going to want to go. Okay, so just to back up a step, this is the kind of the definition of a large language model. If you folks are here, you probably know what an LLM is. I'm listing on this slide a whole bunch of different models. I think one thing that I was surprised by when I first sort of entered this world and started looking at what was out there is just the diversity of models. Forget about the different variants, the fine tunes, the different versions of models, but just the diversity of actual models that have been developed is big. So there's, I've listed 4 open source models. Those are certainly not an exhaustive list, or those are some of the most popular. And there's, of course, a bunch of large commercial models as well. But what I'm really interested in is I'm really interested in what can be done locally, what can be done with limited hardware, and it turns out quite a lot. So one of the challenges that you'll have in getting started is picking a model. You need to figure out what your maximum model size is, okay? And this is a little complicated. So you need to know what your available VRAM is. If you're using Apple Silicon, figure that your operating system and the apps that you're running is going to consume 6 to 8 gigs. So whatever is left over is your operating margin in terms of what RAM you have available that would be equivalent to NVIDIA VRAM. So when a model is built, they are built with 16-bit vectors. Okay, those parameters are 16 bits. That's the precision. That means that every model will identify its size and parameters by billions. And whatever that number is, you can double it, and that's the amount of VRAM that you need in order to run it. Okay, that's at full precision. What has been discovered over time is that models can be quantized, which is a process where those parameter values are their precision is reduced to 8 or 4 bits, and you'll see even smaller quantizations if you follow this stuff closely. Today, Microsoft released the 1.0 version of a server designed to run models quantized below 2 bits, which is an effort to allow extremely large models to run on normal hardware. This is a trade-off. I don't notice much of a difference when I'm looking at interacting with a full precision model versus the 8 or even the 4-bit quantization. Typically, there is some loss of quality, but it's a measured loss. But when you get into the quantizations lower than 4, things can get a little bit weird. So keep that in mind. Essentially, I think you're looking at the model size in billions of parameters, and you're doubling it, halving it, and leaving it at its own value. And those are the 3 possibilities you have in terms of VRAM envelopes for that model to fit into. So you'll see that models tend to cluster around the size of different RAM configurations. When you look at the models available, you'll see that there are models available at the 1, the 3, the 8, the 11, and the 22 and the 30 billion parameter plateaus. Those plateaus, because each of those corresponds to a different memory configuration, those plateaus tend to be where model sizes cluster. You can look at benchmarks. I find the benchmarks at this stage, I find benchmarks a little bit confusing. There are a lot of them, and it's a lot to understand. But there is a leaderboard where you can compare the open models, the free models, on huggingface.co, which is a clearinghouse for all this stuff. It's a good website to get familiar with. So once you figure out your target size, you should try a few models in that size. Now, on this slide, I've listed 2 that I think are really good to start with. Llama 3.2, the 3 billion parameter variation, is Meta's Llama LLM. And they released that in sizes from 1 billion parameters up to 405 billion parameters. But the 3B version is a really good place to start. It will fit into the quantized version will fit into even a 4 gig VRAM device, and so that's a good place to start if you have any kind of NVIDIA hardware at all. The second one on the list, small LM2, comes in sizes ranging from 1.7 billion parameters down to 135 million. So that 135 million parameter variant of small LM2 is small enough to run on almost any hardware released in the last 5 to 10 years. So that's a place where if you want to experiment with extremely constrained models, they're very limited in capacity, but that's what you would be able to run on hardware without a GPU. And if you look on the olamic.com website, you will see that there is a section for models, and all of the models that you can download directly with the Ollama software are listed there, along with their model card and links to other resources and more information. So that's a good place to go to kind of start digging into this stuff. So those are the basic models. But what we're looking at today, the code I'm going to show you today is it's a classification task. Okay, this is a pretty common use case for a smaller model. One of the things that is really interesting about this space is that at different plateaus of, billions of parameters, 3, 8, 11, 22, 15, and 14 is another one that you'll see. At all of those plateaus, um, there are specialized models that are also available, fine-tuned, task-specific models. But what I was going to tell you is that each plateau, emergent capabilities are added. So you're not going to run a model like small LM at 135 million parameters and get it to summarize a graduate level paper for you, or give you the kind of rich feedback on your input that you might be used to getting from commercial models like ChatGPT. But you still can get value and use out of small models. And like I said, one of those things that they're really good for is classification tasks. And so I started working with Llama 3. In fact, I was initially working with the 405 billion parameter Llama 3 hosted on Nebius. I started working with Llama 3, the 3B version, the 8B version on this workload. What I found is that Refuel LLM, the small version that we're going to be using today, it's a pretty impressive for the size of the model because it's specifically tuned for this kind of text processing task. It's really capable, and its capabilities are actually comparable to the big commercial models. And you can see from the chart there that even the small Refuel will compete really well with ChatGPT for classification tasks. Okay, very cool. So you can start with the generic models. You can the more sort of broad-based models, but as you start to figure out what your workload is, this is one of the variables that you can tweak. One of the knobs that you can turn as you try to solve your problem is trying out different models with different capabilities and different fine tunes. Okay, those are things that you can do. Okay, if you want to get ready to follow along with the demo, these are the things that you need to do. You need to have Docker Desktop installed. If you're running Windows, that means that you need WSL installed as well. Okay. You need to download and install a Llama from llama.com. You need to go and pull the model that you're interested in trying out. Create the Open Web UI container. Okay. Oh, I see I've got add models twice on this slide. And optionally, you can create a proxy. Okay. That proxy will take your Open Web UI content that is unencrypted HTTP, and gives you some encryption for it and allows you to run it SSL. So that's an optional component. All of these components, this is what you need to do this stuff locally. Okay. If you're going to work with a remote LLM, all you need to do is just grab Docker Desktop, and that will allow you to pull down the repository and run it in a container, which will make things a lot easier. Okay. All right. Before I get into, actually, I will get into it. So this paper, I got interested in doing some classification work based on finding this paper. I was doing some research for a talk I gave at the Workforce Windsor Essex conference a couple of weeks ago, last month. And they were interested in what kind of stuff that I could bring, along with my fellow panelists on the Mead, Mead, and Moose podcast. And so I was looking into what kind of work I could do on their data. They had a body of job postings that was available to us, among other data that Workforce Windsor Essex has. And so I looked at that job posting data, and I saw that there was some elements in it that were missing that people might be interested in. So I looked up this piece of research, or found this piece of research, which essentially is a little bit of a roadmap or a recipe for getting classified information out of free text. Okay, that's really what we're talking about here. Taking free text and turning it into a JSON object that has some categories and classifications in it. Okay. So it turns out, this is a chart from that very paper. It turns out that using an LLM for this task can be more accurate than traditional methods based on dictionary searches. So it's really interesting. At first I wasn't sure how feasible this was going to be, how capable these tools really would be for this kind of structured task. Like many of you may feel like I kind of had this idea that LLMs were kind of like toy gibberish makers, that it's something that is fun to play with, but doesn't offer a lot of value. But what I've found is that there's actually an awful lot of really interesting tasks that are extremely hard to do with, I guess, deterministic programming, the kind of programming we're all familiar with, and they become kind of trivially easy with a well-tuned LLM. So that got me to sit up and take notice and has kind of spurred my interest in exploring this space. So I mentioned that Workforce gave us job postings. This is what those records look like. Okay, so there's a whole bunch of categorized data. And if you look at the very bottom, there is a text field. And that text field contains the full job description. So it's it's a few hundred words of description of the job, including typically what kind of fringe benefits are offered on the job. And if you look at all the structured data in this job record, you'll see that it has categorizations by the occupation classification. It's got the industry code for the employer. It's got some tags for the name of the job. It's got the location. It's just got all kinds of structured data, but there's nothing here about benefits. There's nothing here about benefits. And to me, one of the things that I'm really interested in this particular space is job quality. Not just like, is there a job available, but what's the quality of that job? And I thought that extracting benefits from job postings might go a little bit distance towards starting to work up, some kind of measure of job quality. So that's why I did this particular task. So I got a slide here that is another capability of Nebius. Okay, this is one of the reasons that I gravitated to Nebius. It's got an API playground where you can take two models and you can compare them against each other, and you can issue the same prompt to both models and then watch and see how they respond differently. Okay, and you can see here that in this kind of amusing example, I'm using Qwen 2.5 and Metalama, and I'm comparing the output that they give me. So it's a really valuable tool, to use Nebius for this kind of work when you're selecting models. It's really valuable, especially if you're working with a model that's big and it's going to be slow on your hardware. You can test in this playground, and it's kind of, you get this lightning fast interaction. So it makes it a lot faster for tasks like fine tuning your model. Again, so for example, if you're talking to a model that doesn't quite fit into your VRAM, you'll end up in a situation called overspill, where the memory and compute that don't fit into the GPU overspill into your CPU and RAM. And that typically brings a significant slowdown. CPU-based LLM activity, it runs 8 to 10 times slower in my experience. So it's going to be massively slower. And as soon as you hit some overspill, that's going to kind of drag your performance way down. But it's viable, especially if you're doing batch operations and you can wait. It allows you to use larger models than your hardware would allow for interactive work. So again, all of that to say, it's really valuable to be able to test things quickly. And that's what the capability that Nebius gives you. Oops. Sorry about that, folks. Where was I here? Okay. So actually, I think what I'm going to do is I'm going to stop that share. Are we all still here? Okay, I can see you all again. We're going to stop that share, and I'm going to walk you through the code that I've got before we get into those results. Um, Before I do that, though, I want to stop and just ask you folks if there's any clarification questions that you'd like to ask. And am I going too fast? Is this too much information? Thumbs up, thumbs down, or a comment would really help me know if I'm pitching this right now. Okay. All right. I'm seeing thumbs up. You guys are sticking with me. This is making sense. Great. Really happy to hear that. So let me show you the code then. Um, Here we go. All right. So this is my little app here, and what we're looking at is the code for the extract script. Before we get into this code, let me show you the components here. You can find this on my GitHub. Here we go. Here we are. Whoop, darn it. There it is. Okay. So this URL, and let me paste it into the chat just to make sure everybody's got it and um, it's not a problem. I don't have to stick on this screen forever, but this is the repository. Now, one thing I want you to notice here is that there are two branches, okay? And those branches are actually just to make life easier for you folks. If you are interested in working with the remote API, grab the main branch. If you want to work with a local LLM, grab the local branch. The differences are trivial, but this makes it a lot easier, I thought, than for me to tell you all the different things that are different, like the slight tweaks that are different between the two versions of the code. Just grab the branch that makes sense for you. Okay, so let's take a look at this code. We're looking at the main extract script, but I want to just kind of walk you through all the components here. So we've got a Docker file, and I am a big fan of Docker. The reason that I enjoy Docker, that I think it's a really valuable tool for developers, is that Docker makes it really easy to pass around a development environment to different people. A kind of a known configuration, a known development environment. That's super valuable. It's super valuable at Parallel 42 because we tend to, like, we're all freelancers, and it just makes it easier to ship code around. Um, and ship a kind of a known configuration around. It's also really valuable in terms of dependency management. I don't know about you, but I hate managing Python versions and virtual environments and all that stuff. I find to be a tremendous waste of time as a developer. So for those reasons, Docker is something that's very much in my toolbox. And this is a pretty simple Docker file that essentially installs a few convenience apps on Linux, then copies requirements.txt into our target folder. And then so requirements.txt, if you're a Python developer, you'll know this is a way that we can kind of make sure all the modules that we need are installed. So in the Docker file, we just install all the requirements from requirements.txt, move this folder, the app folder, which contains all of our code, move that code into the container. Very important. Export our API key. So you'll see that the repository ships with a .env example file. You're going to want to take that example file and either create an API key on your Open Web UI server or create an API key on Nebius and stick that into your .env file. It'll get loaded here into the environment of your Linux server. And then that file never needs to be anywhere near your source control or whatnot. Okay. So that's the Docker file. Requirements.txt. There's actually more requirements than we need just to do the extraction. A lot of these tools are here for the analysis piece, which we're not going to get into today too much. But the analysis piece is something that requires, a bunch of libraries. But essentially, I think we could get away with just requests for the actual data extraction. All right. So also I've got a sample jobs file here. It's just got a few of the jobs from that workforce data file. They gave us a sample of a couple thousand jobs. You've got a couple dozen here, but it's enough to get started. I would say like the utility of this project to you as a developer is as an example. So, it's good to be able to run it and make sure that, you've got your whole environment going. But I think this code is really trivial. Once we get into the actual code, you're going to see how trivial this application actually is. So why don't we do that? I guess we had a few more libraries than I mentioned, but I think that all of those are built-ins except for requests. So we've got our configuration here. This will work for the most part for either of your platforms, either remote or local, but that base URL is one of the things that needs to change for a local server. And you can see here, I've got my local LLM server, which is not the device that I'm presenting from. It's another device on my network. That is my LLM server. Okay. And then this is the Open Web UI the OpenAI. There's so many opens and so many AIs. This is the OpenAI API endpoint that we'll need. Okay. And then if you're a Python programmer, there's not a whole lot here that is going to be surprising. So I'll kind of start down here. Essentially, we open our data file, we grab that job description, and then we call our function to generate the data from the LLM, and that is this guy right here. Okay, and so what extract benefits does is it sends a payload to the LLM. Few things here I want to call out. That in this payload we are sending a model. Okay, and this is the Llama 3 refueled model that I mentioned before. Llama 3.2 is something that you could use. Llama 3.2 would be a good choice again if you have a 4 gig NVIDIA card. This is a quantization of Llama 3 8 billion, so it actually fits into 4.1 gig of VRAM. If you have a 4 gig card, you'll end up with a tiny amount of overspill, maybe 500K or 500 meg or something like that. Probably something you could manage. Anyway, then we have messages. So we have a system prompt. All right. This is an important concept. In talking to LLMs, there's a system prompt that is the kind of the pre-prompt that sets the parameters for the device, okay, or for the model. It tells it who it is and what it does. So that is separate from the prompts, the user prompts. And so when you prompt ChatGPT or another service, there is a system prompt that is issued to the LLM before it processes your prompt so that it understands what your expectations are and what OpenAI wants to give you. Okay, so in our case, this is a pretty complex system prompt. Okay, and this took a while. So we'll probably just abandon the rest of those slides because they're kind of showing the refinement process of the prompt, but it's probably more fun to just look at the code and talk about it together. So I went through a lot of iterations of this prompt, and I would say that it is really hard. One of the things that I found challenging is to know like which knobs to turn to get the desired outcome, and when it's time to think about a different model, or that kind of a change versus thinking about a change in your prompt. I will say that prompt changing and trying prompts is really easy and really fast. So my approach is to select a model and work with that model as I refine my prompt. And what I learned from this project, what I did was a mistake. I started with the biggest model available. I started with Llama 3.2 at 405 billion parameters. It was awesome. It was really easy to get good results from it. But the problem with that is that if you start with a very large model, it may be good to prove the concept or validate what you're trying to do, but you're locking yourself into the most expensive way to do it. And doing text classification on a 405 billion parameter model is just overkill. You know, like I said before, that at different plateaus of model size, different capabilities emerge, right? They emerge from I guess the having more connections and more information. It gets the LLM gains more abilities. But the classification ability is something that you can probably do with very small models. So I kind of regret starting big here and then trying to go small. When we actually run this thing, you're going to see that the performance is not perfect, even with a model that is tuned for classification. So I probably need to revisit. This project is done, so I'm working on other things, but I probably would need to revisit this prompt and do more testing and more evaluation to make it run on my hardware instead of remote hardware. Okay, so what did I do though? I asked it to give me back um, a JSON object. So here we go. I want categories. And this was where I started was very naively. I asked the LLM, tell me what the benefits are. Give me an array of the benefits you find in this job. And what I found from doing that is that every employer describes them differently. So you ended up with way too many variations to get useful analysis out of it. So then from there, I tried asking the LLM to categorize the benefits instead of extracting them. So don't extract that information. Just tell me what category it's in. And that was pretty mixed. And what I found was the model really, really wanted to give me the text from the body of from the body of the text that it was given. It really wanted to do that. So what changed that for me was providing this example or this structure. Here are the categories I want you to use. Use only these categories, okay? So I listed the categories and provided examples. This is a really common pattern in prompting, okay? As you explore the ways to prompt LLMs, this kind of thing is a really common pattern. And this works amazingly well for classification. I'm doing another actually, it's a ranking and rating project, but it uses a similar technique to identify user preferences in order to perform the ranking and rating. And it works really well if you give it this kind of a template so that it knows what to expect, right? And what to do. And then here are some instructions, okay? Very specific instructions to the LLM. And these are all based on refinements based on working with the data. So what would happen is I would run a batch and I would examine my results, and then I would be dissatisfied with those results, and therefore I would come back here and add a new rule for the model. So you can see that I've twice in two different lines, I tell it return JSON. Okay. That's because models, they're so chatty and they want to talk to you and they want to tell you, it's like the like recipe websites online. They want to tell you about how their aunt cooked this in 1942 and et cetera, et cetera. They want to tell you all that, then give you what you want to know, and then tell you some more stuff after. So it can be challenging to get JSON out of it. But one thing that is kind of exciting, I haven't had a chance to try this yet, but in the last few days, an update to Olama was released that uses token filtering techniques to force the model to return only JSON. It's pretty cool. I don't want to, that's a different talk. I don't want to get into how they do it, but if you're using a Llama server, you can actually specify that you only want JSON output. So that's a refinement that would make this work a lot easier. It didn't exist when I did this project, and even so, there are lots of other ways to access LLMs that don't give you that property. So it's not something that you can count on. But if you're using a Llama, it certainly is a tool to know about. So this is kind of the final prompt that I landed on, and it's pretty effective. In looking at it now, looking at this prompt that I wrote a couple of months ago, if I was doing this now, I would probably do it a little bit differently. One thing that LLMs really like is structured text. And so if you use Markdown, everybody knows Markdown. It's like it's a very common way of like providing simple formatting in plain text. Markdown format is something LLMs understand. And so that means that you can use cues, you can use bolding, you can use headings and impose that kind of structure on your prompt, and the model will respond better. The structure will give it more information. And the more context information you can provide, the less work the model has to do, and therefore the better results you're going to get. Okay, so that's the prompt, and that's everything I can tell you about prompting. Uh, then we parse that response, and so you can see that I've got some defensive code in here just to clean up the usual junk that you get besides what you want when you're asking for JSON. Those three items that I've got there. It's going to cover 90% of the challenges you have when you're trying to get structured data back. So if you do download this repository and try to work with it, that's a little nugget that is valuable to look at and think about, incorporating into your own work, because that is pretty decently useful. So once we've extracted them, we basically spit them out to a text file, and Bob's your uncle script's done. So why don't we take a look at that script? Go. Okay. All right. Now, where are you finding people? Oh, I see there's some questions. Okay. Nima. Okay, these are good questions. Yes, system sets the context to what the LLM is doing. So the system prompt is really like your configuration of the machine. And then the specific individual requests would go under user. And yeah, prompts are pretty much always free text. There is a structure to it that's hidden from you. So if you look at, let me see if I can grab one really quick. Okay. Oh, I just happen to have Llama open. So let's take a look at that website, and I will show you what I'm talking about. There is a prompt template. Okay, there's a prompt template provided with every model on the Llama website. And what this template is showing you is how the model is expecting to get your prompts. And these tags can be used to structure your prompt and give hints to the model. So especially when you're working with really weak models, really small, weak models, it's valuable to incorporate those tags so that you can be very explicit about exactly what part of your text is what. One of the things that will happen with really long inputs, and I found this happened a lot to me, is that the model starts to interpret the input on the basis of volume, right? So if 80% of your prompt is data and 20% of it is a question about the data, it's possible that what you'll actually get is a description of your data out the other end, especially if you provide your code or your question or whatever at the front end and then paste a bunch of stuff, you run the risk of some of your actual query getting pushed out of the context window by your data. So you want to be careful about that. But structuring your prompt this way is going to give you a little bit of better performance. So that is the way that you can structure it. And then the last question here, can you force the output of a model to a custom validator? Yes. I don't have particulars to share with you, but the Olama server, the capability to emit JSON is basically a filtering capability, and it understands the grammar of the language. So you can use more complex or more specific um, uh, structures than just JSON. Could be something else too. I think that's something that people are starting to experiment with. It's certainly not something that I've played with at all, but it's possible. So I think that that's an area to explore if you're interested in it. Okay, all right. So I promised you guys that we would look at this. So let's actually run the thing. Okay, so we're in my container in the app folder. Okay, you see there's our extract script. So I don't think that we've looked at uh, the, oh yeah, we have looked at the jobs. So what I did from your repository, there's job sample.json, copy that into a file called jobs.json so that the script will work, or else you'll have to update the file name in the script, whichever way you want to go. This is your output file. We've already got one because I needed to make sure this would run on my hardware before you fine folks got here. So with that, we can run our script. And what we're going to see here is the response from the LLM. Okay, so I'm printing the response from the LLM so that we can see it. And what you can see here is an identifier of the model, a timestamp, and the actual model name. Okay, and then the message is what we want to look at. The message coming back is the message from the LLM. That's its response. Okay, and so in our case, it's responding with JSON, and you can see that as I said, this model is really capable for classification tasks. So one thing that you may note is that we're actually getting what, at least at my glance, looks like valid JSON every single time without filtering output. So that's an advantage of using a fine-tuned model for your use case. You're going to get that kind of improved performance. And so what you want to look at here, well, let's just let this finish. And so if I could, let me see, can I possibly share my screen here? This is getting into some pretty murky territory for screen sharing, but let's see if I can. Oh, it looks like I can. So what you can see now is this is my remote desktop on the Windows server that's actually running Olama. And so what you can see here is that running this script, it's done now, but running that script did almost nothing to the CPU. It slammed the GPU and it consumed a consistent amount of video RAM, right? A steady, consistent amount of video RAM. That's your model. That you know 6.8 gigs, which is I think the usual overhead is between a half and 1 gig. So 5.8 gigs there, that's the size of the model. Very convenient to have capable small models like this. Like I said, that's going to fit into very trivial NVIDIA hardware, something that you probably got just sitting around the house. I mean, if you're a particular type of hobbyist like me. All right, where were we? Here we go. Okay, so let's take a closer look at jobs extracted. Okay, so it's everything that you saw before, right? It's all that information that you saw before, including the text of the job posting. But then we've got a new value here, and that is job benefits. And that's our array that was returned from the LLM. So this one uh, looks pretty good. It's got health insurance. Those health insurance benefits look accurate. So the value of this approach, the approach I took here, is to keep the original text, but to drop it under a category. Okay, so what I get is kind of the best of both worlds. I get the categorization, which is much more reliable for doing things like some kind of structured analysis. I get the category, but then I get the original strings too, so that more work is possible there. And I think that as a pattern, I think this is an approach that I recommend like trying out. It worked really well here, and I think it gives you a lot of benefit. And so then what you can do with this output to validate your work is to one, look at the benefit strings that are in your categories and ask yourself if they're accurate. Now I look here, they're all accurate, right? And then the other thing, and I know Christian is on the call, and Christian helped me out with this this fall. Christian and helped me out by helping me verify, helping me do this validation work. And so what we did to validate these extractions was make sure that this text existed in this body every single time. Okay. And so we had 100% hit rate on that, which is awesome. And then the other measure of quality is how accurate these benefits are. And so, oh, there's one that's bad. So here's a response from the LLM that's pure garbage, right? It's a summary. We got a summary of the job instead of the job benefits. That's going to happen. I'm not really sure. I didn't see that in our run, but that's not useful data. So we would need to figure out a way to either, like we talked about before, either constraining the model to only emit JSON or do some quality checks within our script, because there's nothing stopping you from doing a second pass, right? And that's a technique that I really want to. I know we only have a little time left, but I really want to talk to you about that one. One of the techniques that I have found really valuable is layering prompts. So the project I'm working on right now has a couple of components to it. It selects information, selects data based on rankings. It summarizes data. It summarizes the data after it's been ranked if it reaches a certain threshold. It assembles all of those individual summaries into a rough body, and then I do a refinement pass to actually refine that raw output into something that's good. And so if you're getting inconsistent results, like my experience of it is that when you get inconsistent results is because you're asking the model for more than it can do in one shot. And so breaking your task down into multiple tasks and chaining those requests is a really valuable way to do things. And that brings me to the last thing that I want to mention, which is next steps. So, querying the API directly is a way to go, and it's a great way to learn. Like we all know how to query APIs with HTTP and so forth, so it makes it easy to get into it. But there are tools. By now, we have developed tools for this, and there are platforms that you can use that will make things a lot easier. The one that is most popular and most comprehensive is called LangChain, LangChain. And what LangChain does is it gives you a lot of tooling to do those things that I was just talking about, to do more than just send a prompt and get a response. And then if you want to do more, you have to build all your own infrastructure to do it. I encourage you to do that. That's what I did in my next project. But I think that I'm taking steps towards a goal. And on the next time I work with LLMs, I will likely incorporate LangChain because I've worked with the raw stuff enough that I have a feel for it. And so now I'm ready to kind of move on and work with that more capable platform. So I'll just write that name down in the chat as well. just to make sure everybody gets it right. And that's a Python library. So that's kind of everything I had to show you today in terms of getting started working with LLMs, either locally or in the cloud. And so I'm not sure if anybody's got questions, but I'm happy to help if you do.
I've got a question.
Shoot.
Do you ever have you? I'm pretty new to this. Like I just set up this like a couple of days ago and messed around with LangChain a bit, and also some raw direct IO. And one thing I found is like it gets a bit. It's like it's a new thing as anyone who's programmed, like dealing with a machine that insists on English as opposed to anything else. It's just a bit weird and feels like a bit black magic-y where you tell it to do something and then it doesn't quite do it. And then
Yep.
like for example, I was doing a simple case where you as a user types in the name of a country, and then all I wanted to do is say, is you put a name and you wanted to test, is this a state, either a city state or a nation state, but if it's ambiguous, for example, if I say Congo, then which Congo are you talking about? There's two Congos. So it should return like a question mark. And if you say it's a city that's a fake city like Lilliput, or if a city like Paris, which is not France, it's just a city, it's not a city state, it should give an exclamation mark. And just to do that, I found like I had to give it so many examples. And even now, I don't really know how
Okay.
good it
So,
worked. I used Olama and OpenAI. OpenAI seems to get it pretty quickly, whereas Olama kept doing weird stuff and adding fluff to the answer. And I was just wondering, like, is there something that I'm not doing? Is there something that you can, rather than, because it's like this iteration where it does something and then you say, no, no, don't do that, do this. And then it does something else. No, don't do that, do this.
yeah.
Is there something more formal?
Yes, there is. Prompt tuning is one thing, and I think with proper prompting and good model selection, you can get pretty consistent output. But it is weird as programmers to start to work with these probabilistic systems. Like they just aren't deterministic. You're not going to get the same thing out every time.
Right.
But retrieval augmented generation, RAG, is I think what you're looking for. So in the case that you're talking about, you have a very finite data set that you want to search, right?
Mhm.
And you want to process. So you provide that data set to the model and instruct it that it must refer to that data set. So what you do is you provide that data set. Retrieval augmented generation
Mhm.
generally means that you're providing that data set as tokens. So you're providing it as tokens the LLM can read directly. So you
It's a
vectorize your
huge constraint on what it's allowed to receive.
exactly.
Right.
So this is really valuable for things like documentation search.
Right.
The thing that will constrain you too when you're testing and when you're just trying things out is that there is an awful lot of data preparation and data cleaning that has to be done before you get good results.
Right.
So one test that I did that I thought was really valuable was I got a copy of SQL Server Books Online for SQL 2000. Okay, really old.
Mhm.
But the advantage is that you can get it in one PDF.
Right.
And so provide that to the model. And this is what I did to test it. I provided that to the model, and it was a very small model,
Mhm.
and started taking some blog posts from the mid 2000s of like people talking about problems or challenges they had with SQL,
Mhm.
and pasting those into the LLM that was able to do retrieval augmented generation on the SQL documentation that was extensive, clean, came with lots of examples, very well structured, all that good stuff. And I got amazing results.
Oh,
Amazing.
wow. So you could almost like give it an entire book on any subject. And then
Yep.
when you ask questions, it's basically pretending to be the author. Like it'll say,
You got it.
wrong, or you're missing this, or I don't know about X.
Yeah. And so one of the really valuable reasons that you want to run Open Web UI is
Mm.
that here, let me share my screen. I think I've got Open Web UI open here. And I can show you guys really quick what I'm talking about. Um, Yeah, I do. So, here we go. All right. With Open Web UI, you can, here we go to my workspace, set up knowledge. Okay. You can pre-load a knowledge base with data. Okay.
Mhm.
Um, and it's retrieval augmented generation is as simple as that. You create the knowledge base and then you create a model. Okay. And a custom model in Open Web UI is simply a combination of a system prompt, all your parameter settings, the base model, right? All of those things together
Mhm.
and knowledge. So you can attach a knowledge base to it and build yourself a tool that can search that document or that suite of documentation for you. I've done a lot of testing with this and had some pretty good results. I think that's a really essential tool for the kind of like we're talking about data processing work. We're
Mhm.
talking about trying to use this as a tool in software engineering, not like just creating a platform for people to interact with LLMs.
Mhm.
So tools like RAG, like the JSON constraint for Olama, these are the tools that are slowly starting to develop to allow us to use these things in more comfortably in traditional software engineering.
Right. And the reason you're suggesting the open web UI is mostly just because of the UI lets you shortcut some of the stuff. Otherwise, the RAG thing you could just do independent of open web UI, right? It's just the
Absolutely. Yep,
okay.
lots of ways to do it. But this is just if you
Okay.
like to get started and to because I think one of the things that at least in my experience, like when I was evaluating this, I was pretty skeptical that I was going to get good results.
Mm.
And so I wanted to test all of these things, but I didn't want to spend a lot of time. And that combo of Olama and Open Web UI is going to take you less than an hour to set up, and you're off to the races.
Okay, cool. And sorry, just one more question
Sure.
that is so is there such a thing as this is kind of like applying reinforcement learning on top of a model? And I wonder if there is anything like this or if it's a bad idea. But basically, imagine like we'll take that simple example of creating a JSON that meets a certain schema, which is easy to validate, or I put in some free text and you tell me whether that maps to an exact unambiguous country, city state or a nation state. And then so you give it a bunch of prompts and it's ready to go. But then can you then do something like it's like, okay, before you even think you're ready, here are the 100 questions, test yourself. And then if the JSON fails or if it thinks Paris is a city state, it'll get like a negative reward. And then it'll say, okay, I'm clearly missing something and maybe find some patterns of what it seems to get wrong versus something that you can actually use and go back and come up with a better prompt as opposed to just in the dark, just like trial and error until it kind of looks like it's working.
So one thing that I do is I ask the LLM how to prompt it, and they're
Huh?
they're pretty introspective. They can give good answers about how to prompt them. But the other piece to this is that RAG is the easiest and sort of the lowest level way to do to tune a model, right? So you're taking a model off the shelf and
Mhm.
you're applying, here's some data, here's your reference. But
Mhm.
you can also fine tune a model for your specific use case. Just like today, I was using a fine-tuned model. So that fine-tuned 8 billion parameter model competes with GPT-4, which is, 400 times its size or
Mhm.
200 times its size. It competes with it on this specific task of classification because it's fine-tuned for it. Um,
Right.
and you'll find fine-tuned models for all kinds of things, but also people chain models as well as chaining prompts.
Mhm.
So what you'll see is that people will use models for sanitizing input and output, for either for security reasons or for cultural or whatever reasons. Like you can apply those kind of guards in a separate model.
Right.
You can also chain different models for different purposes to kind of do the thing that you're talking about, which is check up on each other or, process a piece and now you process what the other model processed. All of that stuff is possible. And I'm really just scratching the surface of what can be done. Um,
Mhm.
You know, that like this is so where what you're asking me about now is like this is the edge of my learning journey. This is where I'm at right now is starting to tackle those questions.
Cool.
Yeah, and so I guess for everybody, that's the that's kind of what I had to share today. If you know, I think this stuff is really interesting, and I'll tell you guys that I'm looking for business use cases, and I'm looking for very specifically business use cases for local LLMs that I can work with my particular market and client base. Like that's my objective here. I think there's a lot of power for data engineering work. There's a lot of power for the work I do in terms of consulting and social science research. There's a lot of capability here for those kind of tasks. And so for me, I see a lot of potential economic benefit in this stuff, but you know, I'm sure that the applications are endless. One thing that I was talking about to my mean, median, and moose colleagues about is that after I saw the results of my classification work, I was like, we're never going to put another word cloud on the web again. You know, like the kind of the ways that we had to sort of try to analyze unstructured data in the past that were generally unsatisfying or generally not as useful as you'd want them to be. We're not constrained by that anymore. And I think it's tremendously exciting. So anyway, that's where I'm at with this stuff, and I thank you folks for joining. And I'm sure that there will be more LLM related events at Hackforge in the future, and maybe one of you will be inspired to learn some things and come back and do a talk for everybody else. So maybe we'll see that one day. Anyway, thanks everybody for joining tonight. I really appreciate it. I had a lot of fun, and I hope you had fun and learned something too.